Okay. You ready? How are y'all doing?
One question before we start.
Yes.
For 1.5, did we have the homework for that? Because there wasn't anything to turn it in on there on Canvas.
There wasn't a place to upload the work?
There was the previous 1.6 and 1.5, but since we already just turned in 1.6 and the due date was passed.
Let me see. I did something today with it, I think. Let me see something. I thought I had fixed that. Five, 1, 6.
You did change the deadline.
I did.
Yeah, you did.
Let me go in here.
Like the homework for 2.1 and the 1.5 is the same date, like due date, I think.
Well, what I have here, it says it was due on the 7th, which was right before our test. So look, just do this. The 1.6 homework, just turn it in with 2.1 and 2.2. If you haven't done it, if you've already submitted the stuff for 1.5 or for 1.6, right? That's what you're saying. What do you do with 1.5 homework? Yes.
Yes.
Okay. Yeah. Just submit it with 2.1 and 2.2.
Okay. Thank you.
Okay.
I was just wondering.
Yeah. Yeah. Sorry about the confusion. We're off. We're like a week behind. So, you know, these deadlines, I think I moved these. These are correct. 2.1, 2.2. That's correct. We'll see how that goes. Any other questions? So we'll talk about the test real quick. You should be able to access your grade through Canvas and then also access your the test, like the electronic version of your graded test. And so you can see where I took off points. The class average was a 68.7. The number that I pay attention to a lot here is this thing called standard deviation. And that just tells me how far apart the grades are. Like the bigger the number, the more like there's A's and F's, but not a lot in the middle. And so this is a pretty big standard deviation. You can see it with this bar graph of A, B, C, D's, and F's. You know, lots of A's and B's, not a whole lot in the middle, and then quite a few F's, right? And then here's the actual every student in the class, their score on the test with a bar here that shows what passing is. So that just kind of gives you an idea. You know, I'm sure you can look at the grades and see where you are relative to the rest of the class. And so what I would say is at this point, you know, it's like if you did good, and you know, just keep putting in the same effort, you know, don't take your foot off the gas. If you didn't do well, there's still plenty of opportunity to improve your grade, but something's going to have to change in the way that you're approaching the class. You can't expect to do the same things that you've been doing and then have a different result happen, right? So you know, I'm not going to be texting or emailing you saying, hey, come to my office hours, please. You know, you've got to make the effort to get the help. So I'm here to help. You just need to take advantage of that help. My recommendation would be, you know, when try and visit me during office hours and come in, ask questions. We can go over homework problems, whatever you think would help. A lot of times when I can hear you think through a problem, like you tell me what you're thinking, I can kind of see where you are, where your weaknesses are, and we can address like what you should go back and look at, things like that. So anyways, as far as, you know, like, is this normal? I would say yes. Like this is pretty much what I see in Cal 1 class on the first test. So yeah, we're par for the course here. Any questions on the exam? Okay. All right, so today we're going to do 2.1 derivatives and rates of change. Then next class we will do the derivative as a function. We are still behind. I told you that I don't think we're going to get caught up until we get to the end of chapter 2. So I think right here when we get to 3.1, 3.2 is when we'll be able to catch up. But for now, we're going to do 2.1 today, and then next class we'll do 2.2. Now, in terms of 2.1, we are starting a new chapter, right? So these are the notes that I have available to you in Canvas. The title of the chapter is derivatives. So we spent most of chapter 1 talking about limits, right? It's almost, I mean, your test was almost entirely limits, right? So chapter 2 has to do with derivatives. And if you ask a Cal 1 student who's finished Cal 1 and they're in Cal 2, if you ask them, you know, what's Cal 1 about, they're going to say derivatives. Like that's the main idea of this class. So we're going to really make sure we take our time through this so that you understand it. I think things get, the beginning is a little weird, okay? The beginning is a little weird because when we're in 2.1 and 2.2, we're going to still be doing limits, all right? We're going to be doing limits, so it's still going to be challenging. And then we get to 2.3, and then we get these shortcuts. We get these new formulas that allow us to do things much faster without the limit, which is really nice. But as soon as you're happy about that, then you start to realize that things get complicated again because these shortcuts get complicated. So I would say out of all these sections here, the hardest sections are 2.5, 2.6, 2.7. And by far 2.7 is the hardest because related rates is basically word problems and using everything you've learned in this chapter to solve real world type word problems. Well, they're not really real world because they're just kind of classic word problems in Cal 1 that help you to see the benefit of being able to do this thing called take the derivative of something. Okay, so that's our path. We're going to start in 2.1, and I have some preliminary things that you need to be able to do in order to be successful in these first few sections. So preliminary concepts here. Let me make this a little bit bigger for you. These are things that you should have learned in algebra. All right, and I'll review these briefly. You must be able to find the slope of a line through 2 points using the slope formula. So what I'm saying here is that if I give you 2 points, let's say x1, y1, and x2, y2, 2 points, there's a line connecting those 2 points. And everyone in here should be comfortable first being able to tell me the slope of that line. So you should know this formula that the slope of a line, which is rise over run, is equal to y2 minus y1 over x2 minus x1. I actually went over that in my college algebra class today. So all you do is take the difference of the y coordinates divided by the difference of the x coordinates, and that gives you the slope of the line. That's the first thing you need to know. The second thing you need to know is that if you have 2 points, you have a line that goes through 2 points, you should also be able to come up with the equation of the line. So the slope just tells you the pitch of the line, but you should also be able to come up with the actual equation of the line. And that requires you use this thing called the point slope formula. This should look familiar to you. That's our point slope formula. So what you do is you take one of these points, x1, y1, you replace these values with the x1 and y1, and then you take the slope that you found in that formula and you plug it in right there, and that will give you the equation of the line. Does that all look familiar? Yes. I mean, we're going to get practice with it when we're actually working through this section. The last thing that you need to be comfortable with, this part C, is that you need to understand that if you're looking at a function, okay, so let's say you have some function here called f. If you were to take some arbitrary point on the x-axis, let's call it a, and plug it into that function, you get a point on the graph. And that point has an x coordinate and a y coordinate. The X coordinate is the A, because that's how far you moved over. And the Y coordinate is what you get when you plug A into the function. Right? It's f of A. So a specific example, let me show you. If we did, let's say the function f of x equals x squared, okay, it looks like this, it's parabola. If I were to go to the point, let's say 2, then it's going to point out, it's going to spit out the point 2 and then 2 squared, because you're plugging the 2 into the function. And that's just the point 2, 4, right? And more generally, if I go to the point A and plug it in, I'm going to get a point here, and it's going to be the point A squared. Whatever A is, and then the Y coordinate is whatever you get when you square the A. All right, so that's a specific example of that, but this is the more general idea. Any questions there? We're okay. Landon, I got your chat. Yes, I have already taken care of it. I just haven't updated it in Canvas. I apologize. Okay, let's get going. You ready? You're ready? You're ready? Let's do it. This is it. This is, I mean, this is the foundation, fundamental concept of Calculus 1. And I think when I show this to you, you're gonna realize, you know what, the concept's not that bad. Like the idea, the actual geometric idea of what we're gonna try and do isn't that bad, but achieving it is gonna be the hard part. So let's start off into my notes here. The first thing we're gonna do, talk about like what this section is about. Like we've studied limits, right? Right? We've studied all sorts of different limits. What we're going to do now is we're going to study a very special limit, one limit in particular that is going to allow us to just really go after this one concept. And this limit that we're going to do is actually called the derivative. Okay, the limit. I haven't shown it to you, but I will. It's called the derivative. And what it's going to do is it's going to help us find the tangent line to a curve. And we're going to find out later that this also allows us to find the velocity or the instantaneous rate of change of some function. Again, if this doesn't make sense, don't worry about it right now. In the end, we're going to be able to solve some very interesting problems once we get this concept established. All right. So to motivate the whole idea, let's start with the idea of a tangent line to a circle. All right. So everyone here should be somewhat familiar with the idea of a tangent line on a circle, but I'll remind you, if we take a circle and we take a point on that circle and now select a different point. Okay, so I'm going to select some other point on the circle, some distinct other point. If I connect these 2 points with a line, we call this line a secant line, right? So you basically have a curve, right? A circle is a curve, right? And if you take 2 points on that curve and connect them with a straight line, you get what's called a secant line, right? It intersects that circle in 2 different points, right? 2 distinct points. Now, the tangent line is what you get when you start moving one of the points around and bring it to the other point and put it right on top of the other one. Then you get that thing that's called a tangent line. And on a circle, it's pretty easy to define, because the way a tangent line works on a circle is that if you take the center of the circle and you draw a line out to that point, the tangent line should hit at a 90-degree angle. That's the definition of a tangent line on a circle. Well, I don't want you to think about it that way. I don't want you to think about a center in a 90-degree angle. I don't want you to think about that at all. What I want instead for you to do is think about it more like this line is touching the circle at a single point. There's only one line that does that. Okay, if I try and tilt this line at all, right? If I just tilt it a little bit, I'm going to hit 2 points. There's only one line that intersects the circle at a single point, and that is this tangent line. Make sense? You understand the idea? Now, instead of instead of working on a circle, right, and taking 2 points on a circle and doing that, let's do the same thing, but on just a general function. So let's say we have this general function. And I have some point that I picked, that black point right there. That I'm going to leave that point alone. And now what I'm going to do is I'm going to pick some other point on the curve, the blue point, and I'm going to connect them with a line. That line is called the secant line. Okay. And what I need to do now is I need to drag that blue dot along the curve and get it closer and closer to that other black point until I get to it, right? And notice what's happening to the line, right? We're starting off, we've got like a positive slope, it's pitched up, and then it kind of pitches down. And as that blue point gets closer to the black point, it starts to pitch back up and pitch back up. And then I'm going to get closer and closer and closer. Let me zoom in a little bit here. I'm going to get closer and closer and closer. And then eventually, boom, I get to that point right there. And I have the tangent line. Make sense? The goal of this chapter is, can you find the slope of that line? Okay, that's it. Simple question. If I give you a point, right? If I give you some arbitrary point on a function right there, can you find the slope of that line? That's it. That's all it is. All right. Now to do it, it's like I said, it's going to take some work. All right. So any questions on the general concept? Secant line, move the second point, place it on top of the first point, and then you get the tangent line. Secant, tangent, secant, tangent. Yes? All right. Well, let's start working this out. All right. Let's see what this is going to take. So I'm going to go to some graph paper here. Let's start analyzing the details of what this is going to require from us. So if I take some arbitrary curve here, and let me pick some random point, and let's call this the function f, all right? Let me pick some random point on this curve right now. So I'm going to pick this point right here. I'm going to call it A, all right? And then if I go up to the function, then at this point, who's going to tell me what the ordered pair is here? What is that? What are the coordinates of that point?
F of A.
AF of A, right? That's it, right? So we got some random function and we pick some random point on that function. And now what I'd like to do is I'd like to pick a second point so I can draw a secant line. All right, let's do that. So I'm gonna pick a second point and I'm gonna pick just an arbitrary point out here. I could call it anything I want. I could call it B, I could call it C. I just can't call it A, right? I'm gonna call it X. Why? Because that's the way we always introduce this in Cal 1. So I'm going to call it X, and then I'm going to go up to the function. I have a point here, and that is going to have the coordinates X, f of X. We all good? Okay, so we have 2 points, right? We have 2 points. And so if we draw a line between these 2 points, see if I can draw a line. All right, this right here is the secant line. Well, I said right before we started this, the preliminary concepts, I said that, look, a couple of things we're going to have to be able to do here. If I give you 2 points, you better be able to find the slope of the line between those 2 points. And then also, you should be able to find the equation of the line, right? The equation of the line using the point slope formula. Well, we have 2 points, don't we? We have 2 points. So we should be able to find the slope of that secant line, and we should be able to find the equation of that secant line. So let's do that. Let's start with the slope. The slope of this secant line should be the difference of the y coordinates, right? The difference of the y coordinates. And my y coordinates here, you know what? Let's label these. This is kind of like in the formula, this is kind of like x1, y1, and this is like x2, y2. So if I follow the formula says that the slope is y2 minus y1 over x2 minus x1. If I follow that formula, then I should get f of x minus f of a over x minus a, right? That's just taking the difference of the y coordinates and dividing by the difference of the x coordinates. Any questions? Sure, sure, sure. Okay, now that's the slope of the secant line. Now what I want is the equation of it, right? So this is your slope, right? That's your slope. And now I'm going to go for the equation. The equation of the secant line should be, I'm going to use this, y minus y1 equals m times x minus x1. And I have some options here because on this formula, the y1 and x1, these can be, it can actually be either one of these points. It doesn't have to be the red one. It could be the blue one, but I'm going to use the red one because I've already labeled it x1, y1. And then the slope is actually going to be that right there, right? That's what it's going to be because that's what we just said the slope of the secant line was. So my equation should look like this, y minus, okay, y1 was f of a equals m, which I'm going to write what m is. It's f of x minus f of a over x minus a. And then I have to multiply that times x minus x1, but x1 was a. That is the equation of the secant line. Any questions? Do y'all agree that this seems so far pretty algebra, like this looks a lot like college algebra? There's no calculus here yet, right? There's no calculus. It's just we've got this weird formula. All right. Y'all ready for the calculus part? You ready? So let's think about this. I said that what we want to do is we want to take this point, right? And so let me label it here. We called this point right here, we called that A, and we called this point here X. And now what I'd like to do is I'd like to slide this blue point on top of the black point. So when I do that, I need to move it like this, move it like this, move it like this. And then once I get right there, okay, to the tangent line, let's see, I'm gonna call on someone. Matthew, are you there? Matthew? Okay, let's go. How about Enrique? Enrique?
Yes.
Okay, Enrique. So my question to you is, if I take this blue point, that blue point is X, right?
Yeah.
And if I move it over here and put it right on top of that, what's X now?
Would that be A?
It would also be A, right? X and A would be the same number, wouldn't they? They'd be the same thing. Everyone agree with that? X would be A. Well, wait a minute, hold on. If I slide that point over and X is equal to A, I want everyone to look at this expression right here. And what would happen if X equals A? Let's see what we would get. It would be f of A minus f of A over A minus A. Isn't that what we get? And what's wrong with that?
Wouldn't it be 0 over 0?
It'd be 0 over 0. And that is undefined. Right? We know we can never, listen, we can never let X be A, right? If we let X be A, then there's no definition for the slope anymore. We can't find the pitch of a line. I mean, think about it. If I give you two distinct points, you should be able to find the pitch of the line between the two. But if I give you the same point, right, 2 points and put them on top of each other, there's no slope. It's the same point. How can you have a slope between 2 points or between 1 point in itself? Does that make sense? So this initially would be a problem for us. Like initially we look at that, okay, 0 over 0 undefined. Okay, we can't do it. But that's what the limit was all about in chapter 1. The limit was like, look, we realized that sometimes you get 0 over 0. And as long as we do a limit, there's a way to get around that whole idea. We can still get an answer without actually having to do 0 over 0. Like we can, well, you tell me, if I want to move the blue point over, if I want to make this blue point right here, that blue point, if I want to move it over to here, I need to let X go where? X needs to approach what?
A.
A, right? This X needs to move over and become A, right? We want to know what happens when X goes to A, right? Goes to A. That's what limits we're all about. We're letting X go to something, right? So I'm interested in knowing what happens when I let X go to A here, right? So what I'm going to do now is I'm going to say this. I'm going to say, all right, well, this fails to give the equation of the tangent line because X will be equal to A, and then we get this, right? That equation is no good if I'm trying to find the equation of the tangent line. That equation works perfectly fine if I have two distinct points and I'm just talking about a secant line. But if I'm trying to move the point on top of the other, that equation won't work. So we just need to make one small little tweak to it, all right? So here's the tweak. The equation of the tangent line will be this. It'll still be y minus f of a equals, now I'm going to leave a blank here, and then I still have x minus a. So what I'm telling you is this is still the same, okay? This in blue is still the same. That's still the same. The only difference is this slope right here in front, we can't let x be a, so we're going to let x approach a. So instead of having that out front, I'm going to just put limit x approaches a of f of a, oh sorry, f of x minus f of a over x minus a. So I'm taking this right here, and instead of letting x actually become a, I'm going to see what happens when x gets close to a. Close to a. How close? Remember we had this conversation. Are we close? Are we close? Or yeah, we're real close compared to the sun, right? So we're going to see what happens when x gets really arbitrarily close to a, and we should get in that limit some numerical answer. And that's it. That's it. That is the equation of tangent line. In other words, if I now provide you a function and ask you for the equation of the tangent line at a point, you're going to use that formula, which is going to require you to do a limit, right? You ready for an example? Let's do it. Now, let me copy this while I'm here. By the way, this equation's in your notes, so, you know. All right, I'm excited about this. Here we go. So your first example, find equation of tangent line to f of x equals x squared at x equals 1. All right, so let's look at this visually, what we're going to do, okay? Everyone got that down? I want to show you visually what we're about to do. Okay, here's the function f of x equals x squared. All right, here it is. And let me move our point right here to 1. So I'm going to the point 1, right? I'm plugging x. I said x is 1, right? So I'm going to go to x equals 1, and here's the point on the graph. Got it? See that point there? I want to know what the equation of the tangent line is to this graph right there. Let me show you the equation first. Let me show you the actual line. There it is. Okay. That's the line we're trying to find the equation of right there. All right. The way we're going to do it, though, is we are going to pick that second point. See that second point over here? We're going to take that point. We're going to connect a secant line between them. And then we are going to slide that second point over, and we're going to let x approach a. And then finally, when we get it right on top, well, it disappears here because Desmos is trying to do 0 over 0, so it doesn't know what to do. We are going to get around that because we're going to have a limit. And so that limit's going to tell us what it's headed to. Watch, I'm going to show you something. Right now, I have the computer calculating the slope for us. See this blue line? The computer is calculating the slope to be 4.1. As I slide that point over, watch what happens to the slope. 4, 3.9, 3.8, 3.3, 2.4, 2.2, 2.1. What does it look like it's headed towards?
0 or
2.
2 or 1.
2, right? It looks like it's headed to 2. Let me do something here. Let me make this go from 2, go 0.0. Okay, let me try that. So as I move in here, look at that slope, 2.154, 2.12, 2.11, 2.08. Doesn't it look like it's getting closer and closer to 2? Okay, now when I put the point on top, the computer says, oh shit, I can't do that, 0, 0, right? But it looks like it's headed to 2, right? It doesn't look like it's headed to like 5, right? It's headed somewhere. It's headed to a specific slope. Right now, here's what it'll be, right? There it is. I mean, that's it right there, okay? And I already have the computer set up here to tell me what the slope of it is. The slope of the tangent line is 2. So let's go do it ourselves, all right? That's just visually what we're trying to do. All right, so let's do this. Let's do this first. Let's just do this part first, okay? How about we do that? Let's go right now and try and find the slope of the tangent line. And to do that, what we're going to do is take the limit as x approaches a of f of x minus f of a over x minus a. So this is something you might want to box. This is a formula for just this piece of the formula, right? This is the equation of the tangent line. The equation of the tangent line contains this in front, which is the slope of the tangent line. The only difference between the slope of the secant line and the tangent line is what? What's the only difference between the formulas for the slope of the secant versus slope of tangent? Here's the slope of the secant line, right here. All we do for the slope of tangent is what?
You add the limit.
We add the limit. That's it. That is it. That's the calculus part right there. That's it. All right, let's not overcomplicate it. All right, let's plug things in. Remember this right here, this 1, this is our A. And now what I'm doing is I'm going to rewrite this limit. This is limit x approaches 1, right? X is going to A is 1. F of x, well, we know the function here, don't we? The function is x squared, so that becomes x squared. Minus, okay, now f of a. What happens when we plug 1 into that? What do we get?
1.
1, okay?
1.
And then we go over x minus, now a again, which is 1. Any questions on that? And now, since this is a limit, we learn we do what we did in chapter 1. We look at this, we just do direct substitution. We plug in 1 for x, we get 0, 0, right? This is bad. And now we need some algebra, right? So the algebra we need here is pretty straightforward. Would you all agree? Difference of squares, right? X plus 1, x minus 1 over x minus 1 cancel the factors. Now let X go to 1. What do you get? 2, right? That's exactly what we just saw was going to happen, right? We just saw that that's what happened visually. It was headed towards 2. This is showing us that, right? Algebraically, with the calculus and with the limit, we are showing that that tangent, that secant line is moving, getting closer and closer to 2. All right, so now I have the slope. Let's go back and plug everything else into this formula. Okay, so y minus f of a, y minus, okay, what's f of a? Remember what a is here? It's 1, right? What's f of 1? Didn't we do that already? Here, I'll write it down like this. F of 1 equals, okay, we just found the slope to be 2, and then x minus 1. That's just me replacing all the a's with 1s here. Everyone understand that this 2 we did over here on the left-hand side? F of 1 is 1 squared, which is still 1, and then over here I'm going to distribute the 2 through. Distribute, and then I'll add 1 to both sides. That'll give us a final equation. All right, Valerie, you there?
Yes.
Valerie, what is the slope of the tangent line to this curve at x equals 1? What is the slope?
2.
2. Good. Now, the equation is something different, right? The equation actually draws that line. So here's what I'm going to do. Just to prove to you this works. I'm going to go here. Let me say this. I'm going to open a new graph. Okay. I'm going to graph x squared. Okay. And now I'm going to graph that. Well, let me put the point 1, 1 there. There's that point, right? That's what we get when we plug 1 into the function. And now we got what? Y equals 2x minus 1, right? That's what we got. I'm going to graph it. Y equals 2x minus, here it comes, 1. There it is. You see? We have the line that goes right through that point and is tangent to the curve at that point. Pretty cool, huh? Now you might be asking yourself, who cares, right? Who cares? Well, here's the thing though. If you think about like, let me do this. I think this will maybe resonate a little better with you. Think about a graph that looks like this. Let's say this is time. Let's say in hours. And let's say this is distance. And let's say this is in miles. So you take a road trip, right? You go up to Austin. All right. Here's 1 hour, 2 hours, 3 hours, depending on when you go. It might take you, an hour or 2 to get to Austin. So you start your trip, right? You start the clock, you've gone no miles. And then maybe it takes you 2 hours to get there. And maybe you went, I don't know, a little north of Austin, maybe you went 80 miles. So, at the end of the trip, right? At the end of the trip, you've gone 80 miles in 2 hours, right? But the whole time you're driving to Austin, you're not driving the same speed the whole time, right? You speed up, slow down, speed up, slow down. So you can imagine your graph is a continuous curve, continuous, right? Why is it continuous? Well, when you're driving down the road, you don't just like teleport and all of a sudden you're like in New Braunfels and the next thing you know, you're in South Austin, right? Like it's a continuous path, right? So it's going to be a continuous curve. And so, yeah, I mean, it's great to know that if you connect these two endpoints, the slope of this green line, which is a secant line, would give you the distance you travel, 80 miles, over the time it took you to travel 2, which means 80 over 2, that's 40 miles per hour. This is your average speed, right? That's your average speed on the trip, but that's not telling you about what's happening when you're actually, let's say, passing mile marker or whatever, right? You look down at your speedometer and you see your speed, right? That speed is what we call an instantaneous speed. It's the speed you're traveling at that moment in time. And to talk about speed at a moment in time, you need to do what we're doing right now, which is to get rid of this endpoint crap, pick some point, like maybe you wanted to know half an hour into your trip, right there, right there. You wanted to know how fast you're going right there. Well, what you do is you find the slope of this tangent line. And that slope of that tangent line tells you how fast you're going right there. And then you can see that later on in my trip, maybe here, that slope of that tangent line is going to be steeper, right? Which means I was going faster right then. Steeper, faster, understand? So we don't care about average stuff in a calculus class. We care about instantaneous stuff. And in order to talk about anything instantaneously, you have to be able to get around the 0 over 0 thing. And the only way to do that's with a limit. Okay? That's why they say the limit is at the heart of calculus. Without the limit, there is no way around 0 over 0. All right, so let's do this. Let's do the same problem. Okay, I want us to do the same problem. But this time, I want us to do it at a different point. So I want us to find, you know what, and let's just make it easy. Let's not even worry about the equation right now. Let's just say find the slope of the tangent line to the curve f of x equals x squared and x equals, let's go with 4. Okay. So what's the only thing that's changed here? Shams? What's the only difference now?
The point.
The
X.
point, right? That point is the value of what in our formula? This 4 is going to be the value of what?
Of X.
Not x, careful.
I don't know. F of, I don't know.
Look back at, look at our formula for, okay, so one more up here. Remember, when we started this whole thing out, this point right here that we're going to anchor to and slide the other point to it is always the A, okay?
Okay.
So I call that like a base point. It's like we're anchored there and then we're going to move this point to it, right? This other point will always be X. The anchor point will always be the A. So if we look and we say, hey, find the tangent line to this curve at X equals 4, this is our anchor point. So this becomes the A. Does that make sense, Shams?
Yes, okay.
Okay. All right, so because I'm only asking for the slope of the tangent line, all we have to do is use this formula. Take 2 minutes. It shouldn't take you but 2 minutes to do this. And then I'm going to call on somebody. If you get it wrong, I'm going to drop you from the class. I'm kidding. 2 minutes. Calculate this limit using this information. I just launched a poll. Just let me know when you're done by clicking yes when you're done. half of you are done. It's going to go another 15 seconds. Okay, so I added something here. Just hold off on this for a moment. Don't start working this out, okay? Let's get to this question. Let's see. Chloe, you there?
Yeah, man.
What'd you get? Did you get something for this? I'm sorry?
The slope of 8. The slope is 8.
8. Okay, very good. So this is what your limit should look like. It should have been limit x approached 4. It should have been f of x, which would have been x squared minus 4 squared is 16. And then over x minus 4, you do your difference of squares again. You get x plus 4, x minus 4 over x minus 4. Your x minus 4 is canceled. And now you let x go to 4 and you get 8. Any questions on that? Okay, let's check it. Let's go to the graph real quick. Okay, if we go to x is equal to 4, I'm gonna have to make this axis a little bit. I'm gonna have to be able, there you go. Okay, so if we go to x is equal to 4 this time, move up here to the graph, the slope of this tangent line should be 8 is what we're getting. Does it seem reasonable that that would be 8? I mean, the green one we know is 2, right? And the bigger the number is, the steeper it is, yes? So it seems reasonable that that's correct, yeah? Questions? So the next thing I said is, okay, if you finish that and you're feeling good about yourself, how about do these? Well, then you're just going to sit there and say, I'm just giving you busy work at this point, right? Because who wants to do that for each one of these, right? Seems like an inefficient way to do this, right? It seems inefficient to just try and do this, you know, for each one of these and do all these different limits, right? I don't want to do 1, 2, 3, 4, 5, 6. I don't feel like doing 5 limits right now, right? So watch this. I'm now going to ask you to find the equation, or sorry, let's just do find slope of tangent line to the function f of x equals x squared at x equals, now watch, I'm going to be clever. Instead of me actually fixing the value at whatever, 4 or -3 or -7 or 10 or 20, I'm going to leave it arbitrary. I'm going to leave it variable. I'm just going to leave it at A. Okay. And I'm going to run through the problem. Let's run through the limit. Let's do this limit, but let's replace A. We're in our formula. We're going to replace A with A. We're not going to replace it. Okay. So it's going to be limit x approaches A. Okay, what is f of x? Well, x squared, right? We know that already. Minus, now I'm not replacing a with anything. So what's f of a? Well, I plug a into the function. A squared is just a squared. And then over on the bottom, x minus, and I don't replace a with anything, right? And now this, if we look at this and I now let x become a, right? If I let this x become a and x become a, I would get 0 over 0, but that's okay. I'm going to still do algebra right now. I'm going to realize that the numerator is a difference of squares. It's x plus a, x minus a over x minus a. The x minus a's cancel. And let's see, Leonard, you here? Leonard. Christian?
I'm here.
Christian?
Here.
Yeah, so what do you get here? What's
X
this
plus
limit?
A.
I'm sorry?
X plus A.
Okay, so take the limit though. In the limit, what's approaching what in this limit?
It's A. So A
X is
plus
going to
A.
A. So it'll be a plus a, which is
2A.
2a. 2a. What we have now is a formula, right? We have a formula. We have a formula that will give us the slope of the tangent line. All you have to do is provide me a. Whatever a is, I'm going to double it, and that will be the slope of the tangent line. So like if you go back to the problem we did before, I asked you, where is it? I asked you to find the slope of the tangent line at 1, right? And what was our answer? 2. Well, that's just twice as much as that. I did this one. I said, what's the slope of the tangent line here of this function at 4? The answer was 8. Oh, well, you just double the 4, right? And now I can do all of these quickly. What would the slope of the tangent line here be? -6, right? This one, -14. This one, 20. This one, 40. This one, -1, multiplying that by 2. This one, -16. Isn't that much more efficient? Instead of doing it at like individual values, to do it generically at A and then have a formula? This is our first actual, now I'm going to technically define this next class, but this is our first introduction into that is what we are going to call later the derivative. I'm going to say here, kinda. Okay, we have to make some adjustments. This is kind of the derivative. It's you start with the function and then you do this limit and you come up with this new formula, and that new formula will always give you the slope of the tangent line at some point A. All right. Now, do you all understand that 2A gives us the slope of the tangent line at any value of A, but only for this function x squared, right? Like if I give you a different function, well, then you're going to have a different formula. It's not going to be the same formula. It's going to be different because the shape of the graph is going to be different. Make sense? So I think we should try a new one. Yes, let's try a new one. It's fun. I told you it'd be fun. Did I tell you it'd be fun? I didn't tell you it'd be fun. So this is a surprise for you. Find the slope of the tangent line to f of x equals, all right, how bad do we want to be right now? Do we want to be bad? Let's go with this. X cubed minus x squared at x equals, let's start with 2. I'm actually going to just give you a number. Let's do it at the number first, all right? All right, so now, now that we're in this section, let's kind of like just back up and think about how we're gonna approach this. We say, all right, I'm being asked to find the slope of the tangent line, right? So I know there's a formula for that. The formula for this is limit x approaches a of f of x minus f of a over x minus a. That's the generic formula for finding the slope of the tangent line to any function, is being able to calculate that limit. Okay? I would try, if possible, to get this thing burned into your brain as soon as possible. All right? So that's what I want to do. Here's the function I'm given. And here's the a that I'm given, right? That's the a. So now we're just going to plug things in and see what happens. So this will become limit x approaches, Kevin, what is x approaching? Kevin?
Sorry, my mic thing wasn't working for a second. It approaches 2.
2, okay, keep going. And then,
For the numerator, it's x to the third minus x squared plus 8 minus 4 over x minus 2.
wait a minute, hold on, you did, okay, so this right here, this here
Oh, wait.
is, in the formula is that, right?
Mhm.
And then you're gonna subtract from that what?
Subtract, not add. Sorry.
Oh, don't apologize. This is where we need to be clear on things, right? You don't want to make that mistake on this.
Minus 8 minus 4.
Okay, so what you're doing now is you're plugging 2 into this, right?
Yes.
Okay, so you can do that if you want. You can do that as scratch work on the side. Just figure out what f of 2 is, right? Just plug 2 in, you get 8 minus 4, and that's going to be 4. Yeah?
Yeah.
Okay, and then we plug that in. Very good. Do you all understand that? Everyone got that? Okay, over what?
X minus 2.
X minus 2. There we go.
So f of a, you always plug in the x equals whatever into the function f of x.
Always, yes. Yep. Yep, so this piece right here goes here, that's f of a. And the good thing is f of x, right? F of x will always just be the original function, right? It'll always just be whatever that function is, just slap it down there and then subtract whatever you get when you plug that number into the function, and then over x minus, and then that will always just be a. So let's see where we are. We're at limit x approaches 2. We have x cubed minus x squared minus 4 over x minus 2. Let's just check real quick to see what happens if we let x go to 2 right now. What should we get? If x goes to 2, we should get what? What type? 0 to 0. Good, Enrique. So if you plug in 2 into here and here, we'll get 8 minus 4 minus 4. That's going to go to 0. And then the bottom 2 minus 2 goes to 0. This is bad. And now we need some algebra, right? We need algebra. Okay. I've got bad news. This up here doesn't factor easily, right? Because if it were like x squared minus x minus 4, then maybe it would factor, right? But this does not, unless you remember something from college algebra. So I'm curious to know if anyone knows how we could possibly factor x cubed minus x squared minus 4. Does anyone know how we factor that? Just, I mean, this is a long shot.
Is it grouping or?
So grouping would work if we had 4 terms. If we had 4 terms, we would go for grouping. I agree. But we have 3 terms. I'm sorry, did someone say something? No? All right.
Pull the four
So-
on the other side.
Can you do completing a square?
No, because this is a cubed.
Can
Right.
you do a common factor?
A what?
Common factor?
Like a GCF?
Like putting aside one and then,
You could pull a common factor out of these two, but in order to pull a GCF, you have to have whatever's there in all three. You have to have it in all three. So look, let me show you. We have never run into this in this class, right? We have not run into this problem yet. I'm going to start doing it. Let's see if it rings a bell, right? I'm going to do, just so you know what I'm doing, I'm doing what's called the rational zero test. With synthetic division. All right, let me do it and then see if it rings a bell. What I'm going to do is I'm going to rewrite this as x cubed minus x squared plus 0x minus 4. So I basically put it in descending order, highest power down, and anywhere I'm missing something, I put a 0 in front of it. So I don't have an x term, so I put 0x here. Is that okay? Then synthetic division, you do an upside down division box like this. I put just the coefficients, 1, -1, 0, -4. So 1, -1, 0, -4. And then what you're supposed to do, it comes from college algebra, is you're supposed to look at the number in front and the number in the back, and then you make this list of possible rational zeros, and then you start trying synthetic division. Now, if that doesn't ring a bell, it's okay. You follow me up to this point though, as far as like taking that polynomial and putting it in the box? The number I'm going to put out here is going to come from whatever makes the denominator here equal 0. So 2, right? 2 would make that 0. That's what I'm going to put out here, 2. And then I do synthetic division. So synthetic division works this way. You start with the 1, you bring it straight down, you put a 1 here. Then you multiply 2 times 1, you get 2, you put it here. You add down again, -1 plus 2, that gives you 1. 2 times 1 gives you 2, you put it here. You add down, you get 2. 2 times 2, that gives you 4. And hey, check this out. This is what we want. We want the last number to be a 0. If you do it this way and you use the number down here like I did, you know, just say, hey, what makes that 0? 2. If you use that, you should get a 0 here. Now, what now, right? Okay, what do we do with this? Like, what's the value of this? Well, what this tells me, okay, and this is, see, this is where you go back to college algebra, which was, you know, a long time for some of you, right? What you can do with this now is this. You can use this number here to create the first factor, x, and then what you do is you take the opposite of it. In other words, you just take, remember this was x minus 2, you just slap it down here. And then what remains, these three numbers, 1, 1, 2, are the coefficients of the remaining polynomial. So you should have 1x squared plus 1x plus 2. And the power here, the reason that that's a squared is because we started, what did we start with? What power was that polynomial when we started?
3.
3. So this will always be 1 less than it. So if this had been a 4, then this first term would be 1x cubed. All right, so what this allows you to do, okay? What this allows you to do is actually factor that numerator. So I'm going to come back to this. I'm going to put the limit x approaches 2. And then my numerator, instead of putting x cubed minus x squared minus 4, I'm going to put x minus 2 times x squared plus x plus 2 all over x minus 2. And then these cancel. So if you don't believe that this is true, okay, if you don't believe that this is true, that this equals that, you would have to multiply this all out to prove it to yourself. Like if you just take this and multiply x through here, x through here, x through here, and then -2, -2, -2, I promise you, you're going to get back this up here. I promise it's going to happen. All right. Just a real quick, like show of hands for those of you who are on camera. Show of hands. How many of you remember learning that in college algebra, that is actually a technique for factoring? Yeah. Okay. Super powerful. All right. Super powerful. This is a good example of why it's useful. Okay. Shams, were you going to say something?
Oh yeah, so for the I'm just confused for the 2 when you divide it by 2. Where did you get that 2 from?
When I divided by 2,
The long, yeah, right there, that 2.
that 2, this 2 will always come from, look back up here at the denominator and ask yourself, what number would you plug in here to make this 0? So if you plug 2 in, you get 0, right?
Mm-hmm.
That's the number you'll put out here.
All right. And
So
we
if this said x minus 4, you'd put a 4.
yeah,
If it said x plus 4, you put -4.
okay. Okay, thank you.
Yep. Okay, now let's continue. We've canceled the x minus 2. Now let's let x go to 2, right? We're just going to direct substitute and we're going to get 4, right? We're plugging in 2 here, 2 squared, 4 plus 2 plus 2, we get 8. The slope of the tangent line is 8. Okay, I realize that probably made you a little sick, all right, having to do this, but now you know it's there. It's actually, this is not going to come up on the homework, but it could very well come up on a test, all right, where you have something that you can't factor. So you have, well, you can, but you have to use this technique to factor it. Okay, now we have found the slope of the tangent line, right? What if I asked you now to just, I changed my mind. I said, you know what? I changed my mind. I want you to find the equation of the tangent line instead. Okay, for the same function, right? Same thing. I want the equation of the tangent line at x equals 2. How do you do this? We have the slope of the tangent line, don't we? So when you go back to the generic formula, this is the generic formula for finding the equation of any line, right? We know the slope is 8, right? What's the only thing we need to finish off the equation? What's the only thing we need?
The limit.
We did the limit to get 8, right? So we've got the actual slope of the line. We know the slope of the line, right? The only thing we're missing in this formula to finish it is a point, right? The point that we're talking about, right? So what is the point on this graph that we want to do this through? So go back up here. We wanted to know what was happening at x equals 2, yes? Can you all tell me what the point is that corresponds to this? If the x value is 2, can you tell me what the y coordinate is there? Ash, you're saying 4, right? That's what we get when we plug 2 into the original function, right? So we know that 2, 4 is the point that we're talking about. So I can use that point down here, right? I can say, oh, well, the x1, y1 is the point 2, 4. And so I just replace the y1 with 4, replace the x1 with 2, and then I'll just distribute on the right side 8x minus 16. I'll add 4 to both sides, 8x minus 12. That's the equation. Questions on what I did there? Do you all see the distinct difference between me asking you for the slope of the tangent line versus the equation of the tangent line? Well, they're not two different things. The slope, you get the slope, great. The equation means you got to then go get the point on the graph and put it in there with the slope into that equation. I'm going to check my work. And the way I'm going to check my work is I'm going to go graph this, okay? It was x cubed minus x squared minus 4. Wait, no, that was it, right? X cubed minus x squared. That was the original graph, yes? And we were looking at the point x was 2, and we knew that when we plugged in 2, we got 4. So that's the point we're interested in. And we wanted to find the slope of the tangent line. We said it was 8, but then I went and got the equation. So I'm going to type the equation in. It was y equals 8x minus 12 minus 12. There it is. Okay. We found the line that goes through that point, and it goes through only that point, right? It's tangent here. Wow, it's really, you can't even. I'm just curious what happens if I go in here real far. There should be two different, you see the curve separated from the line at some point. It won't let me go anymore. All right, fine. There's a gap between them. Y'all see this little gap? And there's a gap all the way until you get to that point. It only goes through the graph at one point there. Okay. Something here. Let's do one more example. Find slope, tangent line. To the function f of x equals square root of x. Let's go crazy. 1 over square root of x at 2, no, make it 4 1/2. So this problem, I'm presenting this problem in just a slightly different manner. I'm still asking for the slope of the tangent line to some function. But do you notice I didn't give you x equals a, right? I didn't say x equals this number. Instead, I gave you the point on the graph that I want you to find me the tangent line. So what is a? Red, you look like you wanted to say something.
4.
4. A is 4. It's the x coordinate. That is our a. Good. So graphically, let me go. I'm gonna go do this quickly. We are going and we're looking at 1 over the square root of x. There's the graph. And I'm going to the point 4, 1/2. That point right there. And we're going to try and find the slope of the tangent line at that point. All right. So the a, what Red was saying is, well, look, oops, this right here, 4, that's got to be our a, right? Because it's the x coordinate. All right. So now, since I'm only looking for the slope, I'm going to use the limit. Here, x approaches 4. Okay. F of x is 1 over the square root of x minus, what's f of a?
1 over the square root of 4.
1 over the square root of 4, which is
1/2.
1/2, right? It's actually that point right there. It's 1/2. So I can just put 1/2 here. And then all of that over x minus 4. Questions on that? Right now, if you let x go to 4, you're going to get 0 or 0. So you got to do some algebra. So the algebra I'm about to do This should all look familiar to you, like we've done algebra like this before. I'm gonna get a common denominator. So I have to multiply this one by 2 over 2 and this one by root x over root x. And when I do that, I get 2 minus root x on top, and on the bottom below, they have their common denominator, 2 root x, and then all of that is over x minus 4. Anyone know the next step?
The conjugate.
Conjugate, good. I'm gonna take 2 minus root x over 2 root x all over x minus 4, and I'm gonna multiply by a 1 here, and it's gonna be the conjugate, 2 plus root x over 2 minus root x. Who said that? Who said conjugate?
It was me. Robert.
Oh,
I got it.
Robert, okay.
Yeah.
Robert, how did you know to do the conjugate?
Because we have a, well, we have 2 minus some sort of root at
Yeah.
the numerator at the top. So we
Okay.
wanted to cancel out.
Yeah,
So that,
so you're just recognizing what we've talked about in the past, right? Which is try and get rid of roots with conjugates, right? When you see
Yeah.
roots, then conjugate, right? Okay. So now let's multiply this out. So we get here, you know, we know the middle terms cancel and we just, we get the last terms. That's all that matters. Let's see here. This is going to be limit. X is going to go to 4. On top, let's see, let's call on somebody here. How about Jose? Jose, you here?
Yes, sir.
You following okay, Jose?
Yes, I am.
Okay. So what do you think, Jose? What do you get on top when you expand out this stuff with the conjugate?
So you would get square root of x.
Do the FOIL. Do the first part, you get what?
4.
4, okay. And then what about the middle terms? What have we said about the middle
Oh.
terms when it comes to conjugate? Just
They
cancels,
cancel-
right?
They cancel.
Okay, so then now you just worry about the last terms, this and this.
So that would be x.
X, right? And it'll be minus because you have a subtraction in front of one and a plus in front of the other. So minus X all over. Now we have the common denominator, 2 root X, and we have the conjugate on the bottom, which we are not going to multiply through. And then all of that is still over X minus 4. James, you there?
Yes.
Am I making sense here? Everything good? Understand the
Yes.
algebra? Okay, what are we gonna do next, James? Do you see it?
Next, do we not foil the bottom or not foil? Multiply the bottom of that?
We could, remember our goal here, James, our goal is to try and get this division by 0 to go away, right? Like this X minus 4, when we plug in 4, we get 4 minus 4, it's 0. It's a problem, right? So we're trying to get rid of this. Do you see that we can almost cancel it?
Because we have
Right.
4 minus x on top.
Yeah, so this is almost this, right?
Mhm.
They're just off by a sign. So do you remember what I told you to do if you ever see these are off by a sign?
Was it multiply by -1?
Pull out a
over-
-1.
or
Factor
pull out a
negative one out. Yeah. So I'm going to pull a -1 out, and then it becomes -4 plus x inside here. So that's no longer this. And that's the same as -1. And then you could just switch the order of those and make it x minus 4. And now do you see, James, they'll cancel?
Yes.
Okay. Which will leave us with, let's see. We still have the -1. Do not lose that -1. That was very common on the test. People would lose that -1. So we have a -1 on top. And then let's see, below that, we've got this thing right here. 2 root x, parenthesis, 2 plus root x. And now let's let x go to 4. We should no longer have division by 0. So we have -1 on top, 2 root 4, 2 plus root 4. I'm going through this in detail because students make mistakes on this part. This is -1 over 2 times 2 times 2 plus 2. Right? Square root of 4 is 2, so 2 times 2. And then here, square root of 4 is 2, 2 plus 2. This is order of operations. Let's do what's in parentheses first. So 2 plus 2 is 4. And now I have 2 times 2 times 4. So this is 4 times 4 is 16. So -1 over 16. The slope of the tangent line at that point is -1 over 16. Now, I didn't ask you for the equation, did I? I didn't ask you for the equation of the tangent line, but it would be very simple for me to do it because I know the point, don't I? The point's 4 1/2. So what I could do is just use this formula. Plug in, let's see, y1 is the y coordinates, a half. And then I just got -1 over 16, and then I got x minus 4. That would be the equation. Now I could solve that for y, couldn't I? I could go solve this for y. But Desmos will take it like this. So I'm going to just go type that in Desmos. Y minus a half equals -1 over 16 x minus 4. There it is. We have found the line that is tangent to this blue curve at the point 4 1/2.
I have a question.
Yes.
So because this is only pertaining to the point 4 1/2, that equation is also just for 4 1/2, right? Not that entire.
That's right. This equation is only for that specific tangent line. If we go to a different point on the curve, we will have a different slope and a different equation. Okay, we have 15 minutes and I have a lot to talk about still. All right, so nothing new here, nothing new, but I want you to just kind of clear your minds for a moment. The whole idea here was that I started with a point A, right? And then I picked a second point and I called it X, right? And then we slid the X towards A. And to do that, we took a limit as X approached A. That was this limit right there is what allowed us to slide that X over to the A. I'm going to do something different now. Same setup. Same setup. I want you to think about it this way. I've got this, I've got some curve here. I'm going to pick some point A, come up here. That's the point A, f of A. Okay. I'm going to pick a second point. That second point, I'm not going to call it X this time. What I'm going to call it is A. Well, wait a minute. I can't let it be A because then they'd be the same point, right? But this is A, and then I move to the right a little bit. So isn't that A plus something? I'll call it H. So if this was 3, maybe this is 3 plus 1. Or if this is 3, maybe this is 3 plus a half. Whatever. It's just to the right of A. I go up here. The coordinates of this point are A plus H, f of A plus H, right? A plus H is getting plugged in. So the X coordinate is A plus H. The Y coordinate is f of A plus H. Do y'all see this is the exact same picture as before, just using A plus H instead of X? Draw a line. Missed it. Try it again. There we go. Okay. Now, if I write it this way, the slope of the tangent line will be equal to the limit. Now, it's not X goes to A anymore. What is it? We're trying to move this point over here. Who's going to come up with it? Which one of you is going to see it? What am I going to need to let happen in order to move the point on the right over to on top of the point on the left?
Subtract h.
Subtract h, keep going, Red. You want to get rid of h, don't you? You want to let h get what? Smaller and smaller?
Yes.
Do you want h to go to where?
Go to a.
Yes, well, if h, Red, if h goes to a, then won't this become 2a, a plus a?
Yes.
So you don't want to go to a, you want to go to what?
So 1.
Okay, then it'll become a plus 1, which is still not a.
Oh, 0.
0, good. You want it to go to 0, right? If h goes to 0, it's going to slide that point over. So I'm going to change my formula to let h go to 0. And now I do my slope, which is y2, right? Here's y1, here's x2, here's x1. So it'll look like this, f of a plus h minus the y coordinate over here, f of a, all over. Now the difference of the x coordinates, which will be a plus h, that's x2, minus the first x coordinate, which is a. Is this making you ill, or are you all right? I'm going to do one more thing, and we're going to be where we need to be. On the bottom, the a's cancel. A minus a. So all you have on the bottom is what? H, right? Do y'all recognize this part in yellow? Do y'all recognize that from college algebra? It's called the difference quotient. In college algebra, you cover that. It's called the difference quotient. In fact, in my 1414 class, where is it? Where is it? Oh. Hold on. I thought I had done it. I think it's coming up. I'm not ready there. I'm not there yet. We're about to do difference quotient in my college algebra class. All right. So what we have now, okay, and I need you all to really understand this. What we have now is a second definition for the slope of the tangent line. A second definition, which means that in all the problems we've been doing, you could use this for the slope of the tangent line as well. All right, 2 definitions. So let's go back to the very first problem we did. Let's do this one. Where's the one that had a 1? Hold on. This one right here, right? Remember this one? I asked you to find the equation of the tangent line here. Or sorry, yeah, I asked you to find the equation of tangent line this. Remember we did that? Okay, the first thing we did was we found the slope of the tangent line first. And we used the definition that I had given you before, which was limit x approaches a, f of x minus f of a all over x minus a, right? That's what we had done, check. Now let's do it with the second version. The second version looks like this, limit h goes to 0, f of a plus h minus f of a all over h. That's our second definition. So the only difference here is that we have, I mean, a is still going to be for us 1 here, right? A is still 1, but this limit's going to look different when we do it. Okay, let's do this. This is going to be limit h goes to 0. I'm not going to plug it in yet. I'm going to go f of 1 plus h minus f of 1 all over h. All I did was replace the a's with 1s. All right, Duck, you there?
Yes, I'm here.
Okay, Duck, can you tell me what f of 1 plus h is?
It would be 1, right?
You're going to take 1 plus h, right? You're taking 1 plus h and you're plugging it into the function. So it'd become what?
it'll be 1 square, so it will be 1.
What about the h? Don't forget the h. You've got to plug the whole thing in for x, right? The whole thing goes in here. That whole expression, that right there, that x gets replaced with 1 plus h. So it would be 1 plus h squared, wouldn't it? Do you understand that, Doug?
Yeah.
Okay, everyone got that? We're taking 1 plus h and we are pushing it into the function. And so we're just going to take 1 plus h and square it. Then we're going to subtract from that f of 1. Now here in this part, Duck, this is where you can just plug 1 in. And 1 squared would be 1. And on the bottom, we just have h. And now if we let h go to 0 right now, try it. If we let h go to 0, you get 1 squared, right? Because the h is gone. You get 1 squared minus 1, which is 0. And on the bottom, h goes to 0, so you get 0 on the bottom. So this is giving you 0 over 0, which is bad, right? So you need some algebra now. So I'm just curious, Ash, what do you think? What do you think about that? Are you following this, Ash?
Yes, I am.
Okay, what kind of algebra would you do on this to kind of get over this 0 over 0 thing?
You would first, difference of squares for that.
You would do
1
difference
plus
of squares?
h. Yeah.
Okay, that's fine. Let's do it. So what would it become then on top?
Oh, 1 plus h times 1 minus h.
1 plus, careful, what's the part that's being, this is the difference, right?
Oh,
Your
right, I
difference is
always
here.
mess this up. Yes.
So just treat it like this. What if this was like capital M? M
Mhm.
squared minus 1. Then it would be M,
Times m.
what would M squared minus 1 be if I asked you to do difference of squares?
Oh, m plus 1, m minus 1.
Okay, but M here for us is 1 plus H, right?
Right.
So it'd be 1 plus H
h plus 1.
1
And then 1 plus h minus 1.
minus 1, good, over
H.
H, right? Let's clean those up, Ash.
So factor out an h on top.
Not yet, hold on, clean this up in here. What does this become?
Oh, 2h
2
plus h.
Okay, and then this becomes,
Just h.
there it is. Do you see it?
Yes.
Bam, they're gone. Now, Ash, finish it off. Let H go to 0. What's your answer?
2.
2. Is that the answer we got earlier? Better be, right? Better be. A second definition for the slope of the tangent line. As you can see, the second definition, the algebra is different, isn't it? It's a different sort of algebra we had to do here. Look, compare it to this one. When we used the first definition right here, when we did it right off the bat, we got a difference of squares. We did a factoring, we canceled, we got 2. I would argue this was easier. Would you? Right? I'd say this was easier. But this method got us the same answer. Now, Ash did a difference of squares here, right? Ash did a difference of squares here, which is fine, but you could also have just multiplied this out. Okay, like let me write that. Limit h goes to 0. If I multiply this out, do a FOIL on it, I get 1 plus 2h plus h squared. That's what happens when I do 1 plus h times itself. And then I still have to subtract 1. So I subtract 1. And I put all of that over h. The 1's cancel. And now both terms left have an h. So I can pull an h out of the top and cancel the h's. And now I still get 2 when I let h go to 0. I guess what I'm saying is there's all sorts of different algebra you could have done here to get the same result.
I have a question.
Yes.
For this second formula, when you started to do it, you said, so and on top right there, so it says f of a plus h. You just put f of x for that. Why is that?
what I did here, this is Y2. This
Okay.
is Y1, right? This is X2, this is X1. And what I'm referring to is this graph right here. Remember, we plugged A plus H in. When you plug A plus H in, the X coordinate, right, is A plus H, but the Y coordinate over here, how high it is actually equal to what you get when you plug A plus H into the function, right? You have to plug A plus H into the function to figure out the Y coordinate.
Got it. Thank you.
Yep. All right, I have 3 minutes. I have one more thing I have to tell you, or else you're gonna be like looking at your homework going, what the hell? You're probably gonna be looking at your homework saying that anyway, but so we have, if you notice in all the problems I've done, I've had to write down, right? I've had to say, go find the slope of the tangent line, right? Find the slope of the tangent line, find the slope of the tangent line, find the slope of the tangent line. So we need some better notation, all right? We have this now. If I want you to do that slope of the tangent line, here's what I'm going to write instead. I'm going to write F with the little apostrophe sign. And then in parentheses, I'm going to write A. That is now equal to the limit as X approaches A of F of X minus F of A over X minus A, which is also equal to the limit as H goes to 0 of F of A plus H minus F of A all over H. We have our two definitions. This was the first definition of the slope of the tangent line. This was the second definition of the tangent line. What I'm telling you is that those now are equivalent to this notation. All right. The way you say this is F prime of A. F prime of A. That's the way you verbally say it. F prime of A. So just to make sure you understand what I'm saying here is the problem we just did, okay? This problem we just did. I come here and I ask you to do this, right? Say, hey, everyone, go find the, you know what? We have to do the slope, sorry. If I ask you to find the slope of the tangent line, right? If I ask you to do the slope of the tangent line, what I could also do is this. Instead of writing all that crap, I just do this. If F of X equals X squared, find F prime of 1. That notation means go find me the slope of the tangent line at X equals 1. So in your homework, they're going to give you functions, and then they're going to ask you to find that. And so you just need to realize you're just really just plugging this as your A, and you're just going to plug that A into either one of the formulas, totally up to you which one you use, okay? My recommendation, try it both ways. And I would not marry myself to one of these, all right? I wouldn't be like, well, I really like the first one. I'm just going to stick with the first one. You can have a little bit of polygamy here, all right? You can be with both and be happy with both, all right? Moving forward in this class, moving forward into the next section, we're gonna pretty much stick with the second one. All right, so even though I introduced it this way, this is really the one we're gonna spend a lot of time with. All right, I'm sorry I went a little bit over on time. For your homework, let me just tell you, because I don't want you to get lost here. I think you can do it all. I want to look at the assignment. I might restrict this a little bit, 2.1. So on the homework, if it asks you to graph something using a calculator or computer, that's up to you. You don't have to do it. Number 1, number 2, 3, 4, 5, 6, 7. Yeah. 11. Okay, just go up through 7. Okay, let me clear this out here. For your homework on 2.1 for now, just do the first 7. because I haven't talked about acceleration and velocity yet. And then 25 through 30. Those. Yeah, that's it. All of those tie into today's class. I'll wrap this section up next time, and we'll get into 2.2, the derivative as a function. All right. Any questions? I'll hang out. If not, have a good day. We'll see you on Thursday.
Thank
Have a
you.
good day, sir.
Your homework. Your homework.
I do have a question.
Yes.
So you said that we'll turn in 1.5 with 2.1 and 2.2 then?
Sure. Mhm.
Okay, because I don't know if it's everyone else's, my Canvas is showing even 2.3 and 2.4 are due on the same date.
Yeah, but I think it's next. I think it's set, isn't it set for the 20th?
The 21st.
21st, I'm sorry, 21st. Yeah, so I'm probably gonna make some adjustments to that. Because I don't think we'll finish 2.2 on Thursday. So I'll probably wind up adjusting it. Just the next time we turn something in, just include the 1.5 in there.
Got it. Thank you.